Here we go. Bisection method. This is starting with my notes. So there's 2 sheets there. These are my notes, and then you can have a look at Miss Pontez's notes. Here we go. Bisection method. Bi means to like 2, right? So section means you're going to cut it into 2. So the bisection method is used to approximate. It's not to find the exact answer. It's actually to guess or approximate what the x-intercept of an equation is. Okay, so you might be asking, well, why do we need that if we have a CAS calculator? Why can't we just type it in? Because there are some functions where the CAS calculator cannot solve for the x-axis intercept, or even if you didn't have a CAS and you had a function that you couldn't do, that is, you couldn't factorize, you couldn't solve, you can do this by hand as well, and it gives you a closer view. Even though it's tedious, technically it is a way to find an x-intercept of a function that you're not familiar with. Okay, so it does so by and follows an algorithm. So it repeatedly follows an algorithm where they bisect, which means cuts in half the domain. Okay, literally that's all we're going to be doing. We're just going to keep cutting in half, in half, in half until we get really close to the x-axis intercept. So here's an example just so you can visualize. I've sketched the graph for you so that you can visualize what's happening here. This is your cubic function, x cubed plus 3x plus 6. Okay? If you use your CAS calculator and you said solve for it, yes, the CAS calculator can do it in this instance. Right? But imagine if you were in year 7 and you haven't learnt cubics, you haven't learnt factorizing. They can still, by theoretical knowledge, if I explain to them on a theoretical point, they can substitute and find the x-intercept using bisection method. So they don't have to know how to factorize. Okay, so we can tell the x-axis intercept is roughly negative 1.28 at the moment. Right? This is how the bisection method works. This is your function. We can tell it's somewhere here between negative 1 and negative 2. So I'm going to highlight that domain. We can tell that the x-intercept must be somewhere between these 2 whole numbers, negative 1, negative 2. So what they say is, okay, so we can tell from the graph that the x-axis is somewhere between, let's fill it in, negative 2 and negative 1. So the theory says this. They say, okay, so we know that it's somewhere between these 2. Now, if I found the y values for them, okay, if I found the y values for them at f of negative 1, whoops, let me do that again. At x equals to negative 1, is the y value positive or negative? Positive, yeah? So we could say, all right, this is somewhat, we don't know what the y value is, but if I wanted to find out, it's f of negative 1, right? And whatever that number is, I know it's going to be positive just based on the graph at the moment, right? And even if you didn't have the graph, you could still sub in negative 1 into the function and figure it out. You could say, well, the function was x cubed plus 3x plus 6. So if I wanted to find the x value or the y value, I would then simply say, oh, what's going on with my pen now? Oh, there we go. We would then say it would be negative 1 cubed plus 3 times negative 1 and plus 6. Now, if we work that out, that gives you negative 1 minus 3 plus 6, and we can see that gives you positive 2. Okay, so this is doing it by hand. Obviously, you can do it on a CAS, but the point is, I'm only interested in, is the y value positive or is it negative? Because one of the things that, to find the x-axis intercept, what's the y value meant to equal to? 0, right? So think about this. You chose 2 points. I'm just going to draw a line on the side so you can visualize this. You chose negative 2 and negative 1. Y values, positive or negative, but you know when it hits the x-axis, it should be 0. So that means when you're solving for the x-axis intercept, in a line, as soon as a line crosses through, there must be a positive y value and a negative y value. True? There's always going to be 2 different signs on either end. You can't both be positive, because if they're both positive, you're not going to be touching the x-axis. They can't both be negative, because then they won't be touching the x-axis. One has to be negative, one has to be positive. Then the 0 must be in between. True? So because of that, we say, okay, well, that means if I know the x-axis intercept is somewhere between -1 and -2, what happens is they say, all right, well, here we go, this is my graph. If I took the middle of the domain, so I started off with two numbers, I said -1, -2. Let's call this A, let's call this B. And I've halved the domain, I found the midpoint of the domain. So wherever -1, -2 is, what's the middle of -1, -2? -1.5, right? Then at -1.5, what I'm interested in is the y value at -1.5, is the y value going to be positive or is it going to be negative? Because on the graph we can tell at -1.5 it should be negative, right? And so why is that important? It's because then instead of using -2, I know, remember we said the x-axis intercept has to be between a negative and a positive value. So what we do is we adjust the domain. We make it now from -1.5 to -1. Can you see what we've just done? So we started off with two numbers. We said -1, -2. But we know that one had to be positive, one had to be negative, because 0 is somewhere in between. If you found the middle, the x value, and then you said, well, what's the y value at that point? If it's negative, you adjust the negative side. If it's positive, then you adjust the positive side. And that way you just get closer, you keep halving, and every time you half and adjust that domain, you get closer and closer. What will happen is the y values will go positive, negative, positive, negative, positive, negative, and you get closer and closer to 0. That's the idea. Okay, so you just keep halving, and you always have a positive side and a negative side. But by doing that, it's a lot of process to do, but that's what a calculator does. You're sort of approximating, it just enters a number, and it keeps going and going, follows this algorithm until it reaches the point that you desire. Okay, so that's the idea. So let's try this on a CAS so you get an idea, okay? So here we go. That's the theory. Let's have a look. Let's actually work this out without doing it by hand. We're actually going to enter the data, and I'm going to show you how to do it on a spreadsheet on your CAS so you can fast track your answers. So which two numbers are we starting off with? We are starting off with the left domain. So we're starting off with -2 on the left-hand side. So fill this in, write that as -2. Oh. Ooh. What happened to the signal? All right, we're back. Here we go. On the left domain, so on the furthest left side, we write -2. On the furthest right side, we say -1. Then we find the midpoint. We find the middle of -2 and -1. We find where the middle is. Now, to find the middle, we know that to find the middle, you just find the average, right? So it's just literally whatever. If we called this A and called that B, it's A plus B divided by 2. Now, on my calculator, this is how I'm going to do it. Rather than doing it by hand, because we know the answer is going to be -1.5, but let's do it on a CAS. So grab out your CAS. Let's start off with a calculator. So tap on calculator. Why am I doing that? Because we're going to define the function. I don't want to type x cubed plus 3x plus 6 all the time. So let's go to menu, 1, define, f of x equals to, now what's your function? It was x cubed plus 3 times x plus 6, was it? Yeah, plus 6. To find that, press enter. So this saves me time from finding out f of 1, f of 2, f of 3 to find if it's positive or negative. So in this case, I picked 2 points. I said x equals -1 and x equals -2. So let's say I didn't have the graph to visualize. I can actually work out f of -1, it's positive. F of -2, it's negative, which makes sense because we looked on the graph, we knew that one had to be positive, one had to be negative, and 0 somewhere in between, right? So now we know the left-hand side is going to be negative, the right-hand side is meant to be positive. So just to help you on your sheet of paper, remember this is going to be now negative y value, and this is a positive y value for the right domain. Okay, so just put that as a note. Here we go. I want you to go to Control Doc to add a page. I'm going to teach you how to use the list and spreadsheet. Go to list and spreadsheet to number 4. All right, so you've got a couple of columns. We're going to replicate what you have on your sheet on this paper, on this spreadsheet here. So, first part, you can call A whatever. I normally can't be bothered listing it, but you can label it like Miss Pontes has. I literally just type in the numbers. So I just say -2 for the left side, -1 for the right side. Okay, so we're copying our columns from our table here. Left domain, right domain. Now the next column, I don't want to manually work it out. I want the calculator to work it out. So here I'm going to type in a formula, like you do in Excel. If you've never used Excel, you can type in a formula and it'll do what you want. So I want the answer in C1, so column C, row 1. I want the answer to be the sum of these two, and then divide that by 2, because that's finding the average. Okay, so here we go. I type in equals, press the equals button, just over there, top left corner. I'm going to put in a fraction, so control divide. I type in A1 because it's column A, row 1. So whatever's in that column, I'm going to add it with B1. So column B, row 1. And I want you to divide it by 2 because that's bisection. I'm halving it. You know, I add the 2, I get the total amount, and then I halve it. Press enter. You should get -1.5, which makes sense because we knew the halfway point between -1, -2 should be -1.5, right? What we're interested in, remember, is not whether it's -1.5. What we're interested in is the y value. Is the y value positive or negative at -1.5? So how do you do this? Instead of, we normally then sub this point into the equation and we work out if it's positive or negative. But because we defined it on the previous calculator page, you don't have to rewrite it. You can now write f of what is in this block here. So I type in f, instead of -1.5, I can actually just tell it f of C1. Because whatever was here, this will now take that value and put it into the function I defined on my calculator. That's the benefit of defining it first. Yeah? So if I press that now, see, I'm not interested in the number. I'm interested in whether it's positive or negative. So let's visualize this again. You should get those 4 numbers there, yeah? So what we've just done is this is what I've done. I said, find f of -2. Yes, I found out the y value was negative. F of -1. Yes, I found the y value is positive. I know the x-axis intercept is in between. I found the middle. Halfway between -2, -1 was -1.5. And then I said, find the y value. So f of -1.5. And I didn't care what the answer was. All I cared was, it's -y. Now what's special about this now, instead of -2 was too low, I can adjust my domain now. Instead of -1 to -2, it is now between -1 and -1.5. And my y values are from here to here. If you keep doing this, you keep halving the domain each time and adjust the boundaries, you should get closer and closer to the y value of 0. That's the theory. Make sense? Yeah, so we're going to do it again. So here we go back to our CAS. All right. Now this one, for those who are Excel savvy, you might understand the function called if. If you don't know, this is how you do it on a CAS. In A1, so what do we know? Since this is negative, that's a better value than -2. So instead of using negative 2, we're going to replace it with negative 1.5. But that's us thinking about it. Can we program the calculator to do thinking for us? Where if it's negative, replace the negative domain. If it was positive, replace the positive side. Because negative 1 had a positive y value, negative 2 had a negative y value. So you choose to replace which one, but that's us doing it. Can we tell the calculator to do it? So here, since I know this is the negative side, what I tell the calculator is I say this. Type in equals if fn, that's the CAS version of saying if, and then you tell it a condition. Here's the condition, open brackets. You say if the D1, so if the value of the y value at this point is negative, and if that's negative, then I want you to replace the current negative. All right, so how do I do that? This is what I do. D1, if it's negative, meaning less than 0, so control equals less than 0. So I'm saying if it's negative, in Excel, what this means is that's a condition. The next thing that you type in is if it's true, you put it in a certain value. And then the other one, if it's false. So you got false or true or false. Yeah. So if it's true, if it is negative, then I want you to use C1. So what I'm saying is, what should be in this cell? If it's negative, use this one. If it's not negative, use that one. That's what I'm trying to say. So true, false. So I'm going to type it all again. So C1, A1. Can you see just on the bottom, this is what I typed. Let's read what I'm typing to the calculator. I'm saying, here's the condition. What would A2 equal to? A2 will equal to either C1 or A1. But which one would it choose? Here's the condition. If the answer for D1 is negative, and it's true, use that one. If it's false, so if it's not negative, use this one. Okay, because if it's not negative, then it's positive. So then we go on this side. So here, we can already tell that is negative, so the calculator will choose this one. We'll replace that. So here, if I press enter, you should choose negative 1.5. Okay, so I'm going to type it again. So if I'm going too fast, Ms. Pontes has already typed this Excel for you to see. I'm just going to scroll down so you can follow. Here's the Excel. Here we go. I'm explaining it to you, so otherwise this gets too confusing when you're reading the syntax. But this is what I just typed. And I typed this one because I knew at negative 2, we knew that the y value was negative. So I'm saying, all right, well, if it's negative, this is the condition. If Fn, if I want the answer for the new left endpoint, that will be the result of whatever D1 is. D1's negative, replace the negative side. If it's positive, then keep the left side. Okay, so this is what I'm doing. So here we go. Let's go to the next one so you get a bit more familiar. Let's try the next one. So I've chosen a new x value. Remember the domain was negative 1 to negative 2. We're now making it negative 1.5 to negative 1. But we know that. So how do we tell the calculator to do that? This is what we do. Equals if Fn. Syntax error. You might have inserted something wrong. I need to check what you did before. I'm going to pause this. Can you guys type in the next bit? And I'm just going to go over there and help out Anthony for a bit. Can you type in the next one? Oh, you got it? Okay. Next one. If Fn be D1, so I'm saying if this is now positive, so greater than 0, comma. So if this spot here is positive, then if that's positive, that means I'm going to replace this one. I'm going to replace this right-hand domain with negative 1, And so here I type in B1 if it's true, but if it's not positive, then we will then keep it as, if it's not positive, then it should be, oh wait, what am I talking about? C1, then B1. There we go. Okay, so follow the instructions here. What they're trying to say is, if this is positive, then I will then use C1 to replace the positive side. But if it's not true, keep it as positive. So this is the not true, keep it positive. If it's true, replace it. Okay, true, replace, false, don't replace. Here's the condition. I know the calculator syntax bit is the confusing bit. The theory makes sense, but we're trying to teach the calculator to do what we're thinking. So when I now press enter, we've now set up all the formulas and you don't have to do any more typing from here. From here, you can actually work out the entire table and work out the x-axis intercept. This is how it works. How do we get them to repeat every single formula that we just did? So now we've got the new domain. Let's think about it graphically. We've got the new domain, which is negative 1.5 to negative 1. So let's look at the graph. We are now working between these two. Next step is halving it. So to find the middle, you do the same thing. Add the 2 divided by 2. But instead of doing that again, you can now just copy this formula down. So this is how you copy it down. Can you press shift? See that shift button? Press shift or hold it. Drag across. So I'm highlighting both cells. Do that first. So shift, highlight both cells by pressing right. So you should have 2 cells copied there. Go document. Sorry, menu. Go to menu, data, and fill. That's the only option we got. So what I'm trying to say is I want you to fill X amount of spots. So now, if you press on the cursor, you press down. See, I can drag it down, and what it will do is it will take all the formulas we typed here. What did I type here before? I said whatever these 2 numbers were, add them, divide by 2. And we'll do it for all these cells down here. We'll take these 2 numbers, add them together, divide by 2. Add these 2 together, divide by 2. And we'll do that for this column. This column was find the value, whatever this is. So whatever that value here ends up being, we'll sub it into the function. So I'm doing that for all of those spots. So I'm going to press enter now. Here we go. We're going to drag it down. Drag it to, say, number 10. Now if I scroll up, do you see how the calculator's done it for me? It's now worked out. Negative 1.5 to negative 1. They found the middle between the 2, and it found the y value. Okay, now this is key. If you were to do this mathematically, let's have a look. You've got your domain. You found the middle. The y value of the middle, is this positive or negative now? Positive. Now if it's positive, that means we don't need the negative 1 anymore. The domain was negative 1.5 to negative 1. If it's positive, it's a better positive to choose negative 1.25. So if we go back to the graph, have a look. Let's say I pick the middle. It turns out that the middle, negative 1.25, gave me a positive y value. So what I'll do now is instead of it from negative 1 to negative 1.5, I'm now going to make the domain smaller. I'm going to choose the new positive n. So new positive n should now be between negative 1.25 and negative 1.5. Can you see what we're doing? On a manual basis, this is what we're doing. We just keep halving and halving. But the calculator does for you, because all you have to do now, here we go, let's copy the whole formula down, and so you don't have to calculate. Let's fill it in. Menu, data, fill, and if I go all the way down, This is what you should get. I'm going to walk around to make sure that you're able to demonstrate this bit, because this is now you not doing it manually anymore. The calculator does it all for you. And you can see what the x-axis intercept starts to come to. See, we keep swapping. We adjust the domain, and we keep adjusting. It gets smaller and smaller. You'll see as I keep going down, what's the x-axis intercept coming to? You see how it's starting to repeat itself? It's getting closer and closer to 1.28, negative 1.28. That's the algorithm. You just do it over and over. Okay, so I'm going to pause this video.